Good day. Learn MATLAB with me. I'm Joshua U. Amarga, an electrical engineering student. MATLAB is a high-level programming and numerical computing software widely used in engineering, science, and mathematics for data analysis, simulation, visualization, and system design. It helps engineering students by providing tools to solve complex mathematical problems, create models and simulations, analyze experimental data, and develop algorithms efficiently. Through its user-friendly interface and built-in toolboxes, students can better understand engineering concepts such as signal processing, control systems, circuit analysis, and programming. MATLAB also enhances problem solving and critical thinking skills by allowing students to test designs and visualize results in real time, making it an essential learning tool in modern engineering education. And now let's convert transfer function to state space. Let's solve this given transfer function to state space. GS is equal to 17 over S squared plus 20S plus 7. So GS is equal to CS over RS. Then cross multiply S squared plus 20S plus 7 times CS is equal to 17RS. So it needs a different equation. So take Laplace C double dot plus 20 C dot plus 7C is equal to RS, while C, which is our output, is equal to 17x. So let's assign variables. x1 is equal to C, x2 is equal to C dot. x1 dot is equal to C dot is equal to x2. x2 dot is equal to C double dot is equal to negative 20 x2 dot minus 7 x1 plus r. Therefore, x dot is equal to 0, 1, negative 7, negative 20 times x plus 0, 1 r. And our output y is equal to 17, 0, x, where a is 0, 1, negative 7, negative 20, b is 0, 1, c is 17, 0, and d is 0. Let's code our given example. So let's type num for numerator. Num is equal to, then bracket 17, semicolon, then for denominator is equal to 1 space 20 space 7 semicolon. So t is equal to tf, which is, it means transfer function. So then parenthesis num for numerator, then for denominator, space bracket a comma b comma c comma then d equals tf to ss. So that is the transfer function filter parameters, parenthesis num for denominator, numerator, and then for denominator, then semicolon a, b, c, and d. So after we inputted our code, so click run here in upper right. So in your command window, we will see our t is equal to 17 over s squared plus 20s plus 7. So that is our given. So a is equal to bracket negative 20, negative 7, 1, 0. B is equal to 1, 0. So as you can see, So let's try to um, check this in our solution. So as we can see in our um, MATLAB in our solution, the transfer function is correct. GS is equal to 17 over s squared plus 20s plus 7. As we can see in the A of our MATLAB and the A of our solution is not the same. We obtained 0, 1, negative 7, negative 20, while the MATLAB gave something like negative 20, negative 7, 1, and 0. The reason is that there are multiple companion form conventions. In some textbook, our form is called the phase variable or the controllable companion form. Therefore, the A in the MATLAB and the A in our solutions are still the same. Just like A, B and C are not looks like in our solution, but they are still the same. Now let's proceed to the state space to transfer function. Now, let's use these examples. By the way, these examples are from our solutions earlier in transfer function to state space. In converting state space to transfer function, we can use this formula. Gs is equal to C times Si minus A raised to the power of negative 1 times B plus D. Here, we just need to subtract A to Si, then afterwards find its determinant. So the determinant is s squared plus 20s plus 7. So in this part, the Si minus A raised to negative 1 is also equal to the adjacent over the determinant of Si minus A. So here, before we can find the adjacent, we need to find the cofactor Si minus A. So that is my solution. And Gs is equal to C 17, 0. And the adjacent S plus 20, 1, negative 7, S over the determinant S squared plus 20S plus 7. And the B 0, 1 plus the D 0. After solving all of that, we can find Gs is equal to 17 over S squared plus 20S plus 7. Now, let's code it using MATLAB. First, we need to input our examples. A is equal to 0, 1, semicolon, negative 7, 20, semicolon. B is equal to 0, 1, don't forget the semicolon. C is equal to 17, 0, semicolon. D is equal to 0. Next, let's put SYS is equal to SS for state space model. Parenthesis A, comma, B, comma, C, comma, and D. And don't forget our semicolon. Then let's put TF, transfer function, underscore SYS is equal to TF, or the transfer function, parenthesis SYS, and semicolon. Enter. display, or in short, DISP for display, parenthesis, transfer function, colon, yeah, then semicolon, TF underscore SYS. Then let's try to run this code. So the answer of our code in MATLAB is 17 over s squared plus 20s plus 7. So we can see that they are the same with our answer earlier in our solving.